Hey everyone, in the last video we have started with the definition of error function, complementary error function, and we have also proved two properties of error function. The first property is error function of infinity is 1 and the second property is error function of 0 is 0. So now let's start with the next property. The next property is error function plus complementary error function is equal to 1. So clearly I need to start with the left hand side. The left hand side is error function of x plus complementary error function of x. And let's start with the definitions. Error function of x is 2 over root pi 0 to x e raised to minus u square du plus complementary error function is 2 over root pi, this is x to infinity e raised to minus u square du. And let's take common part together. The common part is 2 over root pi. So inside what remains? 0 to x e raised to minus u square du plus x to infinity e raised to minus u square du. So I can combine these two integrals since this is just a middle of interval 0 to infinity. So I can write down this as integral directly 0 to infinity because this is the common part e raised to minus u square du, combining two integrals. And note that what is it? This is nothing but error function of infinity. That is, in the definition of error function, if I replace x by infinity, I am going to get 0 to infinity e raised to minus u square du, and which is nothing but error function of infinity. So, and in the last property only I have proved that error function of infinity is equal to 1. So error function plus complementary error function is equal to 1. Then let's start with the next property. The next property we are going to prove is error function is an odd function. Odd function meaning when I am replacing x by minus x, I am getting minus of f of x. Odd function meaning when I am replacing x by minus x, I should get this as minus of f of x. So in the definition of error function, what is definition? Error function of x is equal to 2 over root pi 0 to x e raised to minus u square du. In this definition, since I want to prove this as a odd function, I am going to replace x by minus x. So error function of minus x is nothing but everything remains same as it is, only upper limit is going to be minus x now. So this is 2 over root pi 0 to minus x e raised to minus u square du, right? And let's try to simplify this. Okay, so if I try to substitute u is equal to say minus y, so let's see what happens. If u is minus y, then du is minus dy, correct? And what are the changes in the limits in that case? The limit is nothing but for u and y. U is changing from 0 to minus x. So when I am substituting u is equal to 0, y is clearly 0. And when I am substituting u is equal to minus x, minus sign will get cancelled, y will remain with x. So what are the limits in that case? The error function of minus x becomes 2 by root pi, limits are 0 to x e raised to minus sign as it is, instead of u I am writing minus y, but minus y square is nothing but y square only, so it will remain same as it is. And du is minus dy. Let's take this minus sign outside and write it down as this. Okay, so which is not, instead of, if I try to write down this as minus of 2 upon root pi 0 to x e raised to minus y square dy. So clearly this is a definition of error function of x. So I can write down this as minus of error function of x. So what we have proved, error function of minus x is same as minus of error function of x. So clearly this is a OR function. Okay, this property is pretty much important because they may ask you to this property in the exam also, that is show that error function is an odd function. This is a pretty much favorite question, so this is important. Then the next property, fifth property, is we can express error function as series also. Expressing of error function as series. So I can express the error function as series as well. How to express it? Let's start with the definition of error function. Error function of x is 2 upon root pi 0 to x e raised to minus u square du, right? Everyone knows the series for e raised to minus t. Series is 1 minus t plus t square upon 2 factorial minus t cube upon 3 factorial, and I can continue like this. In the definition of, in the series expansion of e raised to x, I'm just substituting e raised to minus t, so that's why I'm getting this alternating plus and minus signs, right? So let's substitute the same thing here as a series expansion of e raised to minus u square. Instead of t, I am going to substitute u square now. So what this becomes, error function of x is 2 upon root pi integral 0 to x. 1 remain as it is, replacing t by u square. Replace t by u square, so that I'll get the series expansion for e raised to minus u square. So this is 1 minus u square plus u square square, so u raised to 4 by 2 factorial minus u raised to 6 by 3 factorial, and continue like this, right? And I can integrate this clearly. This is just a normal integration. Integration of 1 is u minus this is u cube upon 3 plus u raised to 5 upon 5 into 2 factorial minus u raised to 7 upon 7 into 3 factorial, and continue like this. This is from 0 to x, right? So substituting upper limit, I get 2 over root pi x minus x cube upon 3 plus x raised to 5 upon 5 into 2 factorial minus x raised to 7 upon 7 into 3 factorial, and continue like this. Lower limit is going to be 0 since I am substituting u is equal to 0. So this is nothing but series expansion for e raised to x, error function of x. Yeah, thank you.